Good afternoon. Welcome to Mr. Morrow's algebra class. Today we're talking about patterns and expressions. Well, one thing that we got to really understand is that some patterns can be described or represented by using diagrams, words, numbers, or algebraic expressions. And we'll get into the definition of what an algebraic expression is very soon. For first example, we got a couple figures. Look at the figures here from left to right. What is the pattern? And what would the next figure in the pattern look like? Well, when we're looking at patterns, we got to try to really understand what it is that they're trying to describe to us. In this particular situation, we have a three-sided triangle, four-sided square, five-sided pentagon, six-sided hexagon. So for the first question, what is the pattern? Well, I'm adding one side, okay, continuously. So I'm just adding 1, 1, 1, 1. So what would our next figure look like? Well, it would be a heptagon, and that is a figure with 7 sides. So it's going to look something like this. Okay, that would be our next figure. It is a figure with 7 sides. That is called a heptagon. Okay, so pretty easy. Look at the pattern, and we just continued it. Let's look down here at B. B here, we start with the first figure. We've got one red center and 4 white squares around it. Now we got the one red center, but we added 4 more squares, right? We added this guy, this guy, this guy, and this guy. Okay, so we added 4 there. Now, from figure 2, this is figure 1, this is figure 2. From figure 2 to figure 3, again, we added 1 more square to each of the 4 sides, or the 4 corners. So what's happening here? Well, we're adding 4, okay, 4 squares repeatedly or continuously. So what would our next figure be? Well, our next figure is going to be figure 3 here plus 4 more squares. So it's going to be something like this. Our 4th figure would look something like this. We got our red square in the center. We got 1, 2, 3. 1, 2, 3. And we've got 1, 2, 3. And we've got 1, 2, 3. We're going to be adding 1 more, so, or 4 more actually, 1 to each side. 1, 2, this one, and this one. So that's what our 4th figure would look like. That is our 4th figure. Okay? Hopefully that makes sense. So now, let's talk about some vocabulary. A mathematical quantity is anything that can be measured or counted. That's a quantity, anything that can be measured or counted. Now, the value of the quantity is its measure or the number of items that are counted. So, for example, quantity, let's say we're a sports supplier and we've got 12 baseballs. That's a quantity, 12. Now, each one of those baseballs is $10 each. The value of those 12 baseballs is going to be $120. Is the value of the quantity, is the measure of the number of items that are counted. I apologize for that break. Sorry about that. Okay, so let's go back to what we were saying. Mathematical quantity is anything that can be measured or counted. The value of the quantity is its measure or the number of items that are counted. Quantities whose values do not change, though, are called constants. Now, constants are just regular old numbers, like 5 or 12 or 100 or 13 million. Constants do not change. That's why they're called constants. So a constant is very important to know. That's just a regular number. In other situations, though, the value of a quantity can change. Quantities whose values change or vary are called variable quantities. Okay? So let's just go and run through a couple definitions. A quantity. Quantity, a mathematical quantity, is anything that can be measured or counted. Some quantities remain the same. These are called constants. Or others vary. Those are called variables. A variable is a symbol, usually a letter, that represents the value of a quantity. A numerical expression. Numerical expression is a mathematical phrase or sentence. Okay, let me just move this here. Sorry about that. Numerical expression is a mathematical phrase or sentence involving numbers and operation symbols, but no variables. And an algebraic expression is simply a numerical expression which includes one or more variables. So, let us continue. Now, tables are a good way to organize data and recognize patterns. They work like an input-output machine, a machine that takes one value as an input, processes or manipulates it, and gives the value as an output. A process column in the table provides a way to understand what happens to the input values. Let's look at this example here. How many sides are in the 20th figure? Well, let's look at what we were given. Our first figure has 1, 2, 3, 4 sides. Our second figure has 1, 2, 3, 4, 5, 6, 7, 8 sides. Our third figure has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. All right? So let's go through this. Let's see if we can process this and see if we can come up with some sort of a rule and figure out what the 20th figure would be. Well, the first figure has a total number of toothpicks or sides, because these sides are made up of toothpicks in your book. Number of toothpicks is 4. So what did I do to that 1 to make it a 4? Well, I could have multiplied by 4, or I could have added 3. The adding 3 isn't going to work, though, because in figure 2, if I just add 3 sides to 4, I'm going to get 7, not 8 sides. So it's going to be our first choice of multiplying 4 to each figure. So that's how we get figure 1 times 4 equals 4. Figure 2 times 4 equals 8. Figure 3 times 4 equals 12. So for our 20th figure, okay, let's look at n, because n can represent any figure number. What's happening here in the process column is that for every figure, we're multiplying 4 to it. So for the nth figure, we're looking at 4 times n, or 4n. The number of toothpicks would be 4n. Now, back to our original question. How many sides or toothpicks are in the 20th figure? Well, let's just follow our formula. It's 4 times the figure number, which in this case is 20, and that is going to equal 80. 80 sides or toothpicks, because the sides were made of toothpicks. And then what is an expression that describes the number of toothpicks in the nth figure? We already figured that out. That's going to be 4n. Okay, I hope that makes sense to you guys. Let us continue, please. Let's look at another example. You want to set up an aquarium and need to determine what size tank to buy. The graph shows tank sizes using a rule that relates the capacity of the tank to the combined lengths of the fish it can hold. If you want 5 2-inch platis, 4 1-inch guppies, and a 3-inch loach, which is the smallest capacity tank you can buy. I'm sorry about that interruption. The question was, which is the smallest capacity tank you can buy? 15 gallons, 20 gallons, or 25 gallons? Use a table to find the answer. Well, they give you this graph right here. That's given. And if you think about what's happening, I apologize about that little pause there. Okay, so we're looking at this table here, and if we really analyze this table and figure out what's going on, first of all, I want to let you know that these are all intervals of 1, so that'd be 1, 2, 3, 4, 5, etc., etc. These are all intervals of 1. So that's 1, 2, 3, 4. Okay, so what's happening here? Well, when our input, which is the inches, the size of the length of the fish in inches, when it's 0, okay, our output, okay, is 2. So my output here is 2. When the length of the fish is 5 inches, okay, my output is 1, 2, 3, 4, 5, 6, 7. Okay, so I have 7 gallons is what I would need. And then, if my input is 10 inches, that is the length of the fish, well, let's analyze what happened in the first 2 figures, or in the first 2 inputs. And let's see if we can process this and figure out how we got this. Well, it's going to be easy because we started with 0. So what do we add to 0 to get to 2? 2 is the answer, of course. Okay, so it was 0 plus 2. If we use that rule for the next input, 5 plus 2 is 7. If we use that rule for the next input, 10 plus 2 is 12. So now we know how we're processing this. For every input, we've got to add 2, and that's going to give us the output, the number of gallons that we need in that particular fish tank. Well, for our purposes, okay, we wanted 17 inches of fish. We want 5 2-inch plats, that's 10 inches, plus 4 1-inch guppies, that's 4 inches, plus a 3-inch loach. So that's 3 inches, and that's going to be 17 inches. So when we add to this table here, okay, we've got our input of 17 inches of fish, plus our 2 to process this. That is our function rule right there. We're adding 2 every time. And we're going to need an output of 19 gallons. So, which is the smallest capacity that I can buy? In this particular case, I would have to buy the 20-gallon tank. That is the smallest that I can buy. I hope that made sense. Let's go ahead and look at one more example. The graph at the right here shows the total cost of plats at the aquarium shop. Use a table to answer the following questions. Well, how much do 6 plats cost? Well, let's check it out. These intervals are all by 1 by the way. 1, 2, 3, 4, etc., etc., etc. And this is 1, 2, 3, 4, etc., etc. So if I buy 0 plats, it's going to cost me $0. That's this point right here. If I buy 1 plat, it costs me $2. If I buy 2 plats, it costs me $4. If I buy 3 plats, it costs me $6. So let's look at the input and the output, and let's see if we can process this. Okay? We've got our input, and we've got our output. Input is the number of plats, and output is the cost. So we've got 1, 2, actually 0, 1, 2, and 3 right here on the table. 0 number of plats purchased, 0 cost. 1 plat purchased, $2. 2 plats purchased, $4. 3 plats purchased, $6. So what's happening here? Well, I'm multiplying 2 every time. It's $2 per plat. So 1 times 2, 2 times 2, 3 times 2. It works for every single input and output. So our general rule here is going to be figure number times 2. So it's $2 for every plat or input that you buy. So how much do 6 plats cost? That's going to be 6 times 2, which is $12. How much do 10 plats cost? Well, that's going to be 10 times 2, which is $20. Why is the graph in example 3 a line while the graph at the right is a set of points? If we look back, okay, talking about this guy right here, why is this a straight and continuous line as opposed to this, which is just random points? Well, if you really think about this, the number of plats that you purchase must be a whole number. You cannot buy 1.5 plats. So since you can only buy whole number values of plats, you have to have individual ordered pairs or points. You cannot have a continuous line. Now, in example 3 here, you have a continuous line, absolutely, because a fish can be 3.2 inches, for example. So this is a continuous possibility of values, whereas the number that you purchase has to be whole number values. So I hope that makes sense for you guys. Okay, so now, let me just give you one little example so you could understand what I'm expecting for you from the homework. Okay, for example, what if I tell you find the next 2 outputs for, and I give you an input and an output table. And in my input, let's say I go 1, 2, 3, 4, 5. Got -3, -6, -9, -12, blank, and blank. Okay, let's see what is happening here. I am going from 1 to -3, 2 to -6, 3 to -3, 4 to -12, It's pretty simple here. I'm multiplying by -3 each time. So when my input is 5 in this table, I'm going to have -15 because 5 times -3 is -15. 6 times -3 is -18. So I figured that out because in my head, I made a little process column here. I went, well, 1 times -3 has to equal that. 2 times -3 has to equal that. 3 times -3 has to equal -9. So I figured out that my formula here was going to be -3 times the input, n. And that's how exactly it was going to work out. Okay? Another way to figure this out is look at the output. I'm going from -3 to -6, then -6 to -3, then -9 to -12. Well, I'm subtracting 3, subtracting 3, subtracting 3. Okay? That's going to be my processing column. If you notice, 1 times -3, it equals -3. I don't have to add anything to it. I am done. So I have my -15 and my -18 as my two missing outputs. Thank you very much. Have a great day. Hope you learned a lot.